So we have already seen that if we express this table, which we call the partial displacement table, like this, and these are the partial derivatives, and these are the active forces, and these are the inertia forces, and there are two particles A and P. Then it can be shown that F1 dot PD11 plus F2 dot PD12 plus Fin1 dot PD11 plus Fin2 dot PD12 equal to 0 is equation number 1, and F1 dot PD21 plus F2 dot PD22 plus Fin1 dot PD21 plus Fin2 dot PD22 is equation 2. So yes, so here the multiplication is actually the dot product. So now we'll observe one interesting thing. See, suppose you take RA. So this RA, we know that this is a function of Q1 and Q2. Now what is RA dot? RA dot is velocity of A, we know. Then RA dot is del RA, so this is vector, del RA del Q1 dQ1 dt plus del RA del Q2 dQ2 dt, or this we can write del RA del Q1 dot plus del RA del Q2 dot. Now see, this RA is a function of Q1 and Q2, and that means del RA del Q1 and del RA del Q2 will produce terms containing Q1 and Q2. So only one Q1 dot is coming from here and Q2 dot is coming from here. So RA dot contains one Q1 dot from here and one Q2 dot from here. So now if we take this partial derivative, then we'll get similarly if we take del RA dot, if we differentiate it with respect to Q2 dot, then we are certain to get del RA del Q2. So this is actually a great finding, where we see that this del RA dot by del Q dot is same as del RA del Q1. Del RA dot del Q dot is same as del RA del Q2. Or this is same as saying that del VA del Q1 dot is equal to del RA del Q1 and semicolon del RA, sorry, del VA del Q2 dot is equal to del RA del Q2. So these quantities, So these quantities, this and this, are called partial velocities. So these are called partial velocities. So now what we can do in this table, we can replace del RA del Q1 by del VA del Q1 dot, del RP del Q1 as del VP del Q1 dot, del RA del Q2 as del VA del Q2 dot, del RP del Q2 as del VP del Q2 dot. So this is what we can do. Del RA del Q1 is del VA del Q1 dot. So this is what is done, and the rest of the procedure is same. So this is just same. This is just same. So if we call it partial velocity 1 1, if we call it partial velocity 1 2, if we call it partial velocity 2 1, we call it partial velocity 2 2. Then so the same expression, equation 1, equation 2, only this PD has to be replaced by PV. So now the two equations are, copy, let me come over here and page, new page. So edit, paste. So the two equations now are, so PV, 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 PV. So now these are the two equations, and if you check, so from here see RA equal to Q1I, so VA is Q1 dot I, so DRA dQ1, del RA del Q1 is I, and del VA del Q1 dot is also I. So it has to be because we have seen the general relation. We have seen the general relation that del VA del Q1 dot has to be del RA del Q1. Similarly, del VP del RP del Q dot has to be equal to del VP del Q dot. So, and you can check that whether it is so on. So if you write RP, then del RP del Q1 is I, and you calculate the velocity VP by differentiating it, and see del VP del Q1 dot is also I. So this and this are same and has to be. Similarly, if you calculate del RP del Q2, and if you calculate del Q, you calculate VP, and then you calculate del VP del Q2 dot. From here, this is this, and from here it is this, and from here it is this. So this and this are same. This has to be because the general relation we have shown to be true. So this is just a verification. So in Kane's dynamics we use this table, actually the table of partial velocities. So we do not use this, we use this. That means we do not use this. In Kane's method we do not use this, we use this. We do not use this, but we use this. We do not use this, but we use this. We do not use this, but we use this. So thank you.